Hello, good people. Our experiment today would be the lemon battery experiment. This consists of lemons, which act as batteries. So basically, what we're going to do is we're going to have two different conductive surfaces, zinc and copper. And we're going to both insert this into the lemon, and then the electron flow, which is the prominent reaction to most batteries, should act and create a current that can be read off this voltmeter. And if we have sufficient voltage of lemons, then we can use them to power different devices such as an LED light or a computer fan. Yes. To further expand this, we're gonna wire these lemons in series, which should daisy chain them and add up the voltage. This should give us more voltage to give us more power.
Alright.
Lemons. An incision in the side of a lemon.
Okay.
Insert a penny inside. This will act as the first conductor, one of the anodes. Make a second insertion. Insert the zinc strip. It is important that these two do not touch. Alright.
Sorry. I got go.
Now it's time to hook up the voltmeter to our lemon battery to determine the amount of voltage that it outputs. Read the scale.
I'll be darned.
It's outputting, rounded off, about 1 volt.
That's 1 volt.
Which in wired series, 4 batteries in series should be 1 plus 4
We have 6 lemons.
6 volts.
We are now repeating the same process to different lemons. You shall incise the lemon. So you're leaking the battery juices.
Sorry, man.
Oh wait, we're wasting voltage.
Joey, tissue, please.
Yes, good sir. Look how much juice you just.
Josh, you don't have to film this all.
Oh. So here we have it. We have 3 lemons right now. And our voltage right now is 2.43. It was 2.45 a minute ago. The voltage just dropped because we're losing energy right now. And you can see from our lemons, the zinc strap is the negative end, and we connect it with the penny, which is the positive end.
So here we are using a penny and a zinc strip, and it produces 0.97 volts. However, when you change it to a nail, it only produces 0.6566 volts. So a penny, the copper is more conducive.
So here we have it right now, Joey trying to work on the fan. The fan's not working, and he's trying to connect it with a battery we have here. This battery should be enough to power the fan because the fan takes 1.5 volts to move, but right now it's not working.
I'm testing the minimum voltage that the light requires to run. This is 1.5 volts. It's not working. What if we like daisy chain? There's something wrong with our conductive, like our conductive. It's not working on
Even with 5 lemons, Joey, can we show? Even with 5 lemons with a voltage of 3.75, there is no the light does not turn on. LED light required too much voltage. We were only able to power using a
9 volt.
Using a 9-volt battery. However, it's not working now. However, this simple timer only uses one battery. We hypothesized that it would be enough. That's science.
Wait.
Wait, keep the connection. There
We go.
Let's start it. Oh my god, put it back.
Sorry.
Okay.
Okay, well, maybe 4 lemons. 4 lemons. 4 lemons was not enough to power an LED light. However, we hypothesized a simple timer with less voltage would be able to be turned on by a chain of 4 lemons. Okay,
Started here.
well, maybe you can't use the functions, but it works.
Yeah, it's a timer. It doesn't time.
Well, 4 lemons and 6 lemons both could turn on the timer. None of them could time. We hypothesized this because 4 lemons would have too much voltage, whereas 2 lemons have only 1.8, whereas 4 have 2.8. So we are going to try if the functions work. And yes, it is counting down.
It's counting down.
With only 2 lemons.
Yes.
It doesn't rain.
Well, I guess not.
Our project about batteries can be linked to the environment because batteries have a huge impact on the environment. As the search for renewable energy becomes a bigger issue nowadays, green and natural power sources have been the goal of many scientists around the world. The green fuel revolution started when people tried to make biodiesel out of corn and other plants. Because if scientists can create an efficient, clean, and renewable energy source, then we're on the road to a better future. The very simple concept of energy that the lemon demonstrates has been further augmented by scientists as they try to invent clean power sources, such as the hydrogen fuel cell. So, in conclusion about our experiment, our objective of using lemons as a battery was successful. Even if we weren't able to power some items like the LED light or the computer fan, we were able to power the electronic timer, which proves that the lemon can be used as a small, cheap, but inefficient means of electricity. When we tested the voltages of each lemon, they were all different due to the variables that came into play, such as the size of the lemon, the composition of each lemon, and the acidity content. One of the reasons that we weren't able to get the light or the fan to work could be due to the very poor conductivity of the corroded alligator clips. In conclusion, the lemons have proven that they can provide an electrical current, thus being able to be used as a battery.